I'm going to show you how to graph y equals x squared, which is the parent function of our quadratic function. And then we start to learn how to graph y equals a is a number, ax squared. Two situations. Situation 1, the absolute value of a is greater than 1. Situation 2, the absolute value of a is less than 1. Then I'm going to show you how to graph y equals x plus c. Alright, let us graph the parent function. We're going to make a little table just like what we did for our linear functions before. And we say this is x, this is y, our input and output. And we use our 5 little points, which is -2, -1, 0, 1, 2. Pause this video, go ahead and calculate what is the value of y. Alright, when x is -2, -2 squared gives us 4. So y is 4. -1 squared gives us 1. So y is 1 here. And 0 squared gives us 0. So we have 0 here. 1, +1 squared gives us 1. Therefore, we have 1. Last one, 2 squared gives us 4. Therefore, we have 4. Now that you finish calculating, what you can do is you can write them down in points. This point is -2, 4. This one is -1, 1. This one is 0, 0. This one is 1, 1. This one is 2, 4. Now we can start to graph it. Remember, this is a quick sketch and not perfect. I will show you something really good looking after this, after we finish doing by hand. Okay, I'm going to graph 0, 0. I'm going to graph 1, 1. I'm going to graph 2, 4. Okay, and then I'm going to go ahead, connect it. You might want to say, why you only graph half of it? Because for quadratic function, we have an axis of symmetry. This axis of symmetry in our parent function is our y-axis. Remember, symmetry is something you can fold it. You fold it and then you got exactly the other half. For this reason, I'm going to fold it and I'm going to go ahead get the other half, just like when I'm in the art class. Or maybe when you're in art class and you draw one half, then you fold it and you can put the other half on the other side of the paper. And this y-axis become axis of symmetry for our parent function. Now, the parent function is all done. Let us go look at what if we do this by using GeoGebra. Let us use GeoGebra. We're going to graph the parent function of our quadratic function, y equals x squared. Now, as you can see here, we have a point 0, 0. We have a 1, 1, -1, 1. We have 2, 4, and a -2, 4. Now, you just learned how to graph the parent function. The next one, we're going to graph y equals ax squared. We're going to graph y equals 3x squared. This is the form y equals ax squared, where absolute value of a is greater than 1. We need to keep this parent function because it will save our time. And we're going to draw a little table. And we have our x and our y's. For the x, we continue to use -2, -1, 0, 1, 2. Now, earlier we already calculated y values is 4, 1, 0, 1, 4. Since we have a 3 times x squared, which means every y value in this box, in this table, we can multiply by 3. So 3 times 4 is 12. 3 times 1 is 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 4 is 12. Now, you just got a whole new set of points. We can write out the points. We have -2, 12, -1, 3, 0, 0, and 1, 3, and 2, 12. If you are graphing by hand, this is the time you start to plot these points on your graph. Then you will see what the graph of y equals 3x squared look like. Now, let's take a really quick look. When we talk about axis of symmetry, means you can fold the graph. They're going to perfectly fit each other. Did you see? This is your axis of symmetry. Why? Because look, you have a 3, 3 here. You have 12, 12 here. Symmetric, right? You have a 1, 1 here. You have 4, 4 here. Symmetric, right? Okay. Now, to save your time and also appreciate the modern technology, I think we can go to GeoGebra, see what is happening if I plot this one on the GeoGebra. To save your time, I already plotted y equals 3x squared by using GeoGebra graphing calculator, and this new one is our blue colored graph. Our parent function y equals x squared is the green one. As you can see, when the parent function times a is 3, this new graph, the blue one, is closer to y-axis. Did you remember what you learned in our chapter of linear functions? In a situation like this, we say a vertical stretch happened. Yes, you're right. When the absolute value of a is greater than 1, we talk about a vertical stretch. But wait a minute, what if it's a negative 3x? Let's try. Let's take a look at here. We have a y equals negative 3x squared. Put a squared here. Did you see we have a new guy? This new guy is the red graph. The red graph compared with the blue one, the red one is reflection over the blue one, reflected over x-axis. Therefore, if you have a negative symbol, a reflection over x-axis occurred. And then you need to look at this a. A here is 3. A is greater than 1. It gives you vertical stretch. And if it's negative, negative gives you reflection over x-axis. So, 2 transformation happened. Let's look at one more. What if it's, let's say, 1/3 x squared? I just graphed y equals 1/3 x squared. This is the orange color. As you can see, it still has the axis of symmetry, which is y-axis. That is the axis of symmetry of this new graph, orange color. However, compared with the parent function, y equals x squared, And the blue one, y equals 3x squared. This orange one is further away from the y-axis. What do we call it? We call it vertical shrink. Now together we practiced how to graph the parent function. We build our table and use our 5 little points, and we hand graphed it. Then we go to GeoGebra. Of course, first we used our table. We did a little bit of multiplication, -2, -1, 0, 1, 2, and we got all the points. Then we used GeoGebra. We graphed y equals 3x squared. We understand if we have a 3, that means a vertical stretch happened. The factor is 3. And then we try to graph -3x squared, also by using GeoGebra. And we understand if we have a negative symbol tells us a reflection over x-axis occurs. And then we look at 3. 3 tells us a vertical stretch occurred, 2 transformation. And then we look at our new one. The new one says 1/3. This time, the form y equals ax squared. The a is less than 1. Okay, so 1/3 is greater than 0 and less than 1. Now, we say a vertical shrink occurred. Why do I put a in the absolute value? Because sometimes you might have a situation like this. You might have a situation say y equals -1/5 x squared. It asks you what happened. You're going to take care of 2 steps. Step 1, you're going to say negative symbol tells me reflection over x-axis happened. And then you're going to take care of this 1/5. 1/5 is greater than 0 and less than 1. Therefore, you're going to say vertical, very crowded here, okay, shrink occurred. We surely did not forget this form. This form is called y equals x squared plus c form. Y equals x squared plus c. Okay, so this plus c is positive 3. This one, c is negative 3. What's happening? This is what's happening. When you see this form, a vertical translation happened. Vertical translation. If it's a positive, c is positive, you're gonna go up. If c is negative, the graph gonna go down. How many units? C is positive 3. You're gonna go up 3 units. C is negative 3. You're gonna go down 3 units. Let us look at our graph. I just plotted y equals 3x squared plus 3 on GeoGebra. Why do we do that? Because 3x squared, as we have studied earlier, it's a vertical stretch, which means this blue graph is closer to y-axis than this parent graph. And plus 3, did you see the parent graph? This point is at 0, 0. That's the vertex is at 0, 0. But this new graph, the vertex is at 3. The C gives us this new vertex. That is 0, 3. The green one I just graphed is the parent function y equals x squared minus 3. As we have discussed earlier, if it's minus 3, a vertical translation happened. The graph gonna go down, new graph gonna go down 3 steps. And the new vertex is 0, -3. This is how we graph quadratic function, parent function, y equals x squared. Y equals ax squared. We might have a vertical stretch, vertical shrink. We might have 2 things happening with a reflection over x-axis. We also graphed y equals x squared plus c. Remember, c gives us vertical translation.